Hey there, everybody. This is episode 2 of 4, SOHCAHTOA, right triangle trigonometry and how to use it. This is going to focus exclusively on sine and inverse sine. This is Mr. Bourne, math teacher from Minnesota. Alright, so what we're focusing on here is just the SO part. Sine of an angle is equal to the opposite side divided by the hypotenuse. Alright, so let's get a sense on exactly how to line up what numbers go where and that kind of thing. So our little smiley face here, Mr. Angle. Um, we're gonna go with both sides, but here we'll just start up on top. All right. So suppose we want this angle, and we're gonna be talking about that angle right up there. Our opposite is gonna be as far away from that smiley face as possible. Opposite side is gonna be 4, and our hypotenuse. Let's see if I can angle it here. Yes, I can. There we go. Our hypotenuse is going to be 5. Okay, so what we have here is we've got our opposite over hypotenuse, our 4, and our 5. So 4 over 5. Sine of an angle is equal to 4/5. Okay, but it can change around depending on where the angle is. So suppose our angle is right down over here. Okay, so our opposite side is no longer right next to it. Our opposite side is going to be furthest from. So we're going to position that there. And hypotenuse doesn't change. So now, instead of 4/5, our ratio is going to be 3 over 5. Okay, so you know where things go. You're getting a better sense here. Let's actually do some calculations and figure out some angle measures. Alright, so I've got this right up there to remind everyone. So, sine is opposite over hypotenuse. And supposing we're wanting to find this angle up there, we're going to actually calculate it. Okay, our opposite is 4 over 5. 4 over 5. Okay, that's good. Now, how do we find our angle? I mean, we want to find that A. That's going to be some degree measure, right? Okay, let me just go off on the side here and show you a principle of algebra that I think you already know. Now, you know how, like, if we've got something like this, something simple, 4x is equal to 20? Yeah, we can divide by 4 and we can figure out x that way. But another really great way to figure out x, get it all by itself, is to multiply both sides by the inverse of 4. And this is what it looks like. We're going to multiply both sides by 1/4. That's the inverse of 4. And what that does is that means this 4 and the 1/4 get canceled out. X is all by itself, and that's what we wanted. And 1/4 times 20 is 5. Okay, now this little problem did not have anything to do with this triangle, but I'm just kind of showing you how we're going to use an inverse to figure out the angle measure. So I'm going to write this out. The sine of our angle A is equal to 4/5. We need the inverse sine to get A all by itself. So here we go. Sine, that little -1, and we're going to write that here. What we do to one side, we do to the other. And what that does is that means these quote-unquote cancel out, and A is now all by itself. So A is equal to the inverse sine of 4/5. And now we can figure out on the calculator. So press the second key before you press the sine key. So second sine, and now we've got sine with the little inverse. Oh, hey, before we do that, let's make sure we're in degree mode. Little trick for that, to see it really quick, put in sine of 90, and if we get a 1, we're in degree mode. Yep. Okay. So our calculation that we wanted was inverse sine. What was it? Oh, 4/5. Inverse sine 4/5. Hit the enter button, and there we go. That is our degree measure, 53.13 degrees. rounding it to the nearest hundredth of a degree. 53.13 degrees. And that's approximate, that's not exact. Okay, now just for fun, let's find the angle over here. Okay, same process as before, opposite over hypotenuse. Now the opposite angle is 3 and the hypotenuse, well, it's still 5. Alright, remember the setup? The inverse sine is needed. Like this, and we get some canceling, so to speak. Our angle is going to be equal to sine inverse of 3/5. Okay. Second sine key, that's inverse sine, 3/5, and 36.87 degrees rounding up. And that's degrees. Okay, so here's the other way to use sine, and this time we're not going to use inverse sine. This is where we are given an angle. There it is, right there. And we want to find a side length, like x right here. So, opposite over hypotenuse. And we're given the angle measure, so that A, we're going to stick in 30 degrees. So here's what our work looks like. Sine 30 degrees is equal to x over 8. Okay, now the name of the game is getting x all by itself, so we got to multiply both sides by 8. That'll get rid of that 8 in the denominator. So multiplying both sides, 8 times sine 30 is equal to x. So here's where we can calculate. 8 multiplied by sine 30. Aha! The missing side length is 4. So now, there we go. We can fill in 4. Now just in case you thought there was some magic going on here with sine 30, here's actually what sine 30 looks like all by itself. Aha! It looks like a half, essentially, 0.5. So when we multiply 8 times 0.5, that's where that 4 comes from. Just showing you what's underneath the hood. Okay, now in this case, the hypotenuse is missing. We've got our angle measure, 50, and we want to find x. There it is. Found x. Ha, old joke. Okay, so going in for A is going to be 50 degrees. And opposite over hypotenuse. So that would be 13 over x. So here's what our calculation looks like. Sine of 50 is equal to 13 over x. Now, sometimes students at this point say, there's no way I can get x all by itself. It's in the denominator. No, you can. Just multiply both sides by x. You can do that. It's fair. Multiplying both sides by x means it's gone from the denominator, and now it equals 13. Oh, it doesn't look any better than before. X has still got some stuff there. It's not isolated at all. Well then we'll divide both sides by sine 50. And what that does is that cancels it out this on the left side, and we have x is equal to 13 divided by the sine of 50. Here we go. 13 divided by the sine of 50. Alright, so that's not a clean number, it's a messy number, but well, let's just round it to the hundredths here, so it'd be 16.97. Now, one thing that you can do as a shortcut in the future is when you have to solve for the denominator, just think to yourself, if I take this and this, they can swap places. And there's your calculation right down there. This stuff right here that you see in the red, that's just the algebra. But when you get to do about 10 of these, you'll realize you can just swap them and then carry on. Okay, so here's the last example. This is a quote-unquote so-called real-world problem. Okay, so you are a radio tower engineer, and you can see by line of sight, so here's where you are, right down here. That's where you are, and you're looking by line of sight all the way up to this other tower here, Tower 2. And you know the distance is 890 meters, and it's a 43 degrees bearing from Maple Road, and here's Maple Road. So, alright, first things first, let's fill in some information on our picture. So the hypotenuse of this right triangle is 890 meters, and it's a 43 degree bearing from Maple Road. So right down here is 43 degrees. That's that angle. The second tower is accessible by walking from Maple Road on a footpath. How long is the footpath? Alright, so our footpath is this red part right here. So you go off of Maple Road, you got to jog through the woods here to get to tower number 2. And you want to know how far that is. This calls for so. That would be sine of an angle is the opposite over the hypotenuse. So let's see, the sine 43 degrees is equal to the opposite, which is our unknown x, over the hypotenuse 890 meters. Okay, so if we multiply both sides by 890, that will isolate x, and that will tell us how far in meters that red footpath is. 890 times the sine of 43. There we go, 606.97 meters. We'll just round it up to 607. So 607 is approximately equal to x, which is the distance. I'll abbreviate dist. Oh yeah. Label your answer meters. Otherwise your instructor will get mad. Okay, that's it for episode 2. Hope that helped.